today's webinar series. I'm happy to be your host, and today we'll look at the sunlight pump. So this series is aimed at people who have just received their first sunlight pump and would like to learn how to set it up, want to know what the stats of it are, and we'll dive quite deeply into these topics today. What is helpful for today's webinar is if you've got access to a couple of documents. We've got a data sheet, a quick guide, and an app manual, all of which you should have been sent by us prior to receiving the pump. So first off, let's have a look at the pump itself. It's got a nice and sturdy frame, which keeps it protected from bumps and damage, and it makes it very transportable. We've got our user interface on the top, and underneath the user interface are the controlling electronics. Then, moving on, we've got our pump head over here, with an input and an output. The pump head itself uses a progressive cavity displacement system. If I take it apart, it looks like this, a little bit like a screw and a thread. So as the screw turns around, water is being pushed through the thread, and the faster the pump runs, the more water is being pushed through the system. Next, let's have a look at the stats. To move along, you can just grab the data sheet as well, and we'll quickly run through the single points. So first off, you see that it pumps up to 22 cubic meters per day. So this means that we pump about 45 liters per minute. And this rate is achieved if we give it the maximum capacity through the solar panels. That means we have an optimum setup and the pump gets all the energy it needs to pump water. If we have a solar panel that is rated with less capacity, say we only let it run with a 100-watt panel, we'll obviously not be able to achieve these high rates of water flow, except for if we've got absolutely no height which we need to overcome. Then we see the second point. It uses the maximum power point tracking system. What this means is that the controlling electronics make the very most of what the solar panels deliver. So it always is on that sweet spot to make sure that the solar panels get all the power that the sun delivers. Then we've got the point 0.5 horsepower, which equals 373 watts. This is the power of this pump, so that you can compare it with other pumps. The pump mechanism we already explained, progressive cavity displacement pump mechanism. And as you see, we've got an online configuration tool, which you can find on our website. And with this, you can really set up your specific example of your sunlight pump. So in the online configurator tool, you can simulate your setup, changing the distance which you want to pump, the height which you want to pump, and the solar panel array which you are using. So your solar panel array would be between 100 and 500 watts, depending on your application. The display on the user electronics gives you a fast overview. So in case you've got warnings or errors, these will be shown, and using the manual, you can find out which errors or warnings are meant exactly. You can operate the pump with these two buttons, and you're always told what is going on exactly if you're paired via Bluetooth with your smartphone, if power is being delivered to the pump or not. So currently there are no lights on, our cables are not connected. this means the pump is obviously in an off state. The Bluetooth interface, the next point, helps us to connect with our smartphone. We'll have a closer look at that later in the series. Inside, there's a water flow switch, and this switch makes sure that water is actually flowing, because the pump could be damaged if it were running and there would be no water flowing through the system. So this water flow switch makes sure that water is flowing, and as soon as water is not flowing anymore, after a certain given period of time, the pump will automatically turn off. Then, on the other hand, we've got another sensor. This is not an integrated sensor, but one that we can connect with the pump, so there's an interface for this sensor, and that's overflow switch. It looks like this and can be used to fill up tanks. So if the water overflow switch reaches a certain level, it will send a signal to the pump, telling the pump to turn off. Or if you are receiving water from a tank and do not want to empty the tank entirely, you can set it to a certain level, and once it drops underneath that level, again it will send a signal to your pump and tell it to turn off, to not continue pumping anymore. So obviously you can run the sunlight pump with solar panels. However, there's also the opportunity to run them via batteries. This is in case you want to run the pump during times when there is no sun, or if you want to extend your periods into the morning, into the evening, a little bit further. You also have the option of, in combination with a charge controller, to load to charge your batteries with the solar panels in case you've got any excess energy that the sunlight pump is not using, and then you can use these batteries in the evening for home appliances or any other purpose you've got for these batteries that have been charged throughout the day whilst your pump was running and the solar panels got energy from the sun. So if we move forward to the more technical aspects of the pump, we'll find a little chart underneath. And first off is the total dynamic head. This is noted at 40 meters, and that means that our total dynamic head is made up of the height to which we pump the water, which is made up by the suction side, the pressure side, so water that is flowing into the pump would be the suction side, water that is flowing out of the pump is the pressure side, and then we obviously have some pressure losses within the hoses, so that depends on distance of the hoses and also diameter of the hoses. Longer distances and smaller diameters mean more pressure loss. Next off is the suction capacity at sea level, which is noted at 7 meters. This means that at sea level, we can place our pump at a maximum of 7 meters above our water source. This is already very high. Ideally, you will place it much closer to the water source, so less height difference. You see the little note, and the note mentions that when you go above 0 meters at sea level, which is usually the case, or very often the case, you will note that the suction side loses capacity. So that means for every 1,000 meters you gain in height, you lose 1 meter of suction capacity. This is simply a physical phenomena which we need to take into account when we set up our solar sunlight pump system. Next off, we've got the maximum water flow rate at 45 liters per minute. As mentioned before, this is the flow rate which you achieve if you've got perfect conditions, all the power you need coming from the solar panels, and you're not pumping to high heights, and you've got very little pressure loss in your hoses. Next off are 2 points which sometimes could cause a little bit of confusion. So these will be the range of maximum power point voltage. The range of maximum power point voltage is basically where your controlling electronics track the voltage of your solar panels. And the much more important aspect is the range of the open circuit voltage. And the important aspect there is the top. So this is starts at 17 and goes up to 65 volts. And these 65 volts are the maximum that these electronics can take. That means that if your solar panels deliver more than 65 volts open circuit voltage, you will damage the electronics of the pump and potentially render it impossible to use. How can you find out if your solar panels deliver more than 65 volts, or how can you find out how much open circuit voltage your solar panels deliver? You can check this almost in every case on the back of your solar panel. So here we've got an example, and here you've got a little sticker on the back of the solar panel, and mentioned on the sticker, besides other points such as your wattage, is obviously also the open circuit voltage. Here we've got a solar panel with 180 watts, and our open circuit voltage is at 21.5 volts. This means this solar panel is perfectly fit for the sunlight pump, because it's in this field of 70 to 65 volts. If we were to set this panel in series with another panel, the voltage would increase. So we need to add the open circuit voltage of each panel to the next. So with 2 panels here, we'd be at 43 volts open circuit voltage, which is still within the capacity of the sunlight. Next off, we've got our maximum input current. This is at 9.5 amps, and this is the maximum amperage that our sunlight pump can take. Here, if we exceed the amperage, we will not damage the pump, but the pump has a cutoff point of these 9.5 amps and will simply not be able to take up any more input current. So if our solar panels have more than these 9.5 amps, cutoff point is there. Again, this information can be found on the back of the solar panel. Next, we've got our maximum input power, which is at 500 watts. And if we use a panel array with a total of 500 watts, we will be potentially able to pump water further, a little bit further into the evening, a little bit more in the morning, and potentially when there's mild clouds or a lot of clouds, you'll be able to get a little bit more out of your system. But under optimal conditions with lots of sun, you will not necessarily require a total of 500 watts to get the maximum water flow out of your pump. Then you've got the operation of the pump, which is 0 to 50 degrees. That's the recommended industry standard for pumps like this. Same goes for the temperature of the storage. Again, this is an industry standard, and make sure to use your pump and store your pump at these levels. So storage would be between -30 and +55 degrees. Pump dimensions, you can see for yourself, quite compact for the power that it delivers. The weight is at 14 kilograms, which makes it portable. 14 kilograms. And for the inlet, we've got a foot valve with a strainer. We'll have a closer look at that a bit later when we set up the pump. Good. You see the type of enclosure, IP65. This means it is sprinkler waterproof, so it can it's not bad if water gets onto the pump in small amounts, but you need to make sure that it is not submerged underneath water. This is a scenario that can happen when you've got it placed in a well or close to a water source with varying surface levels. And when the pump is submerged underneath water, it can take quite serious damage and will need repair or replacement. So make sure that you don't ever place your pump in an area where it is danger, where it is danger to be flooded. Ideally, you place it a little bit elevated onto an elevated area. You can do this with, for instance, a frame or any other idea you've got. Good. If we move on to the second side, the back of the page, we'll find these charts and give you a quick explanation. The first shows you the performance of the pump, depending on the height and on the input power. And what you can read out is the flow rate, so how much water will be flowing out of the pump. I want to mention especially that the input power on this side sometimes causes confusion. So the input power is what arrives in our cables. So not the maximum power that your solar panels deliver, but the actual power that arrives at the pump. To find out what the maximum power is that arrives at your pump, you can use the Sunlight Pump app, which will show you this power displayed on your smartphone. So again, the input power does not equal the maximum power that the solar panels deliver. Let's take an example. We say we've got our pump and we want to pump water to the height of 20 meters. So we'll need to use this line here, which says 20 meters at the end, and we've got our input power of 200 watt. So we follow the line of 200 watt up to our 20 meter line, and once it hits it, we can track this point here. I'm not got a pen to show you more exactly, so we'll just need to make do with my finger. So we follow the 200 watt line up, get to the 20 meter line, and then we follow horizontally back onto the flow rate, and we'll find that we're somewhere around 23, 24 liters per minute, which are being pumped if we've got an input power of 200 watts and we want to pump to a height of 20 meters. So in the next table, we'll find out about the efficiency of the Sunlight Pump. And for the efficiency, we see that the efficiency is a little bit lower, obviously, at low input power and at low heads. So the lower the head is, we see here the circular element. The first one is a 5 meters head. We've got a fairly low system efficiency if we are at low input power compared to if we are at high input power and at a high total dynamic head. So the total dynamic head, say we would take a 20 meters, which is the X, which is here, and we follow the line. We can see the system efficiency increases. The higher the input power is. And what you can take away from this chart, or the main takeaway, is the system efficiency increases with higher input power and with a height between about 15 and 40 meters. We are in this field here, so in the optimal field of system efficiency. Some people are confusing system efficiency with water flow. So just because the efficiency decreases does not mean that the water flow is lower. It just means that the input power that we're getting is not translated to water flow as efficiently as in this fuel pair. One thing I forgot to mention on the above table, you see that the cutoff point is at about 5 litres per minute. So if we fall underneath 5 litres per minute, you need to be aware that the water flow switch, which I mentioned before, will not be deactivated. So if it's activated, this means water is flowing, and if it's deactivated, the water flow will, this means the water flow is stopped or fall underneath our required 5 litres per minute, and then the pump will stop by itself to prevent damage to the pump head mechanism. Good. On the last page of the data sheet, you'll find an example of a battery setup. So you'll see the solar panels, the charge controllers, batteries. Here they are set up in series, and the sunlight pump, which is the output of all our energy. We've got, if you look behind me, exactly this setup. We've got our batteries, we've got our solar panels at the back, which aren't connected, and most importantly, we've got our charge controller. All of this is not yet connected, but we'll have a look in the next part of the series, which will be how to set up solar